Hello Year 5, hopefully you managed to watch my fraction video before you had to go at these questions, otherwise I think you might have found it a little bit tricky. So these were the questions that you tackled today. We've returned to doing some more just sort of straightforward addition problems because I think it's really good to keep your mental math skills sharp, so being able to add numbers together quickly and efficiently is a really good skill to keep practicing. So last week we were looking at fractions with addition, so I thought we'd return to just doing some basic addition sums. Okay, so this was your question, and when I looked at this straight away I suddenly thought, what were those things that you reminded me of, those strategies that you reminded me of in class about completing these kinds of sums and thinking about the mistakes that you could make. So one of the things that we talked about was actually it's a really good idea to put the biggest number at the top of your sum. One of the other things that we could do wrong is that we could write the numbers down. So I'm just looking and making sure each of my numbers match what's in the question. I've lined the numbers up correctly, so all the hundreds are in the same line or the same column. And same with the tens, the units, and then the thousands. And I'm also thinking about when I start to add these numbers together, I'm thinking really clearly about numbers that I can add together really quickly without having to count on my fingers. Okay, if you do need to do that, that's okay, but sometimes there's easier numbers that you can add together to start with. So I'm looking here at 9, 7 and 9. Well, I know 9 add 9, or 2 times 9 is 18. And I'm going to think now 18 adds 7, so I've got to add 2 to 18 to make it 20. So if I take 2 out of that 7, I'm left with 5, so it's 20 add 5. So I'm making sure that I'm writing my 5, and I'm going to then take my 2 over here. It reads as 25. Make sure you're not carrying over the 5 and then making it 52. Okay, I've got 8, 5 and 1, so I know 8 add 2 gives me 10. And then that would be 15, 16. Okay, so instead of working down in order, you've got to be careful that you don't leave any numbers out, but actually 8 and 2 was much faster to add together. Okay, 9, 4, 2 and 1. Right, 9 add 1 makes 10. 4 and 2 is 6, so that's 16 again. And then 1, and then we've got 1 and 7. Sorry, 1 and 6 makes 7. So the answer is 7,665. Hopefully your answer matches with mine. Okay, on the question page, I said to you to try and do this one mentally. It's really good for you to have mental math skills, okay, rather than having to rely on doing sums all the time. Now, for most of you, you would need to do some kind of jottings, which is absolutely fine, but just trying to count up in your head. So remember, when you're subtracting, you can also count up. So what I do in my head, I wouldn't need to do anything. I wouldn't need to write anything down for this. Now that doesn't mean if you did need to write something down, there's anything wrong with that. There isn't. But what I am doing in my head is I'm counting up, and I am counting up on a number line. I'm finding the difference between these numbers. Okay, now this is what I'm doing in my head. I know I'm going to add 5, and that's going to get me to 900. Each jump I make in my head should be taking me to an easier number to calculate from. So I now could just jump right to the end and say 900 up to 1,000 is a difference of 100. So then all I've got to do is add together 105. Now that took me probably about 15 seconds to do. Most of the time was spent me trying to write clearly on this board. Now in my head I could do that probably in under a couple of seconds. Now most of you are really able to do it like that. So if you can't do it in your head, I would think about a number line. Okay, and the more you do that, the more naturally it will happen in your head. Now what I want to show you is doing this as a subtraction sum. You probably would have got the right answer, okay? However, what I think is really interesting to see is how long, I'm just going to make this a bit bigger, how long it takes you to actually do this because of the exchanging. So my numbers match, okay, everything, I'm ready to go. 0 subtract 5, right, can't do that. I can't exchange from that column. I can't exchange from that column, I can't exchange from that column. So I'm going to have to exchange, make that a 0. Now remember, when you're exchanging, you can only exchange between a column that is next to each other. So I go back, 0 subtract 5, still can't do it. Okay, so I'm going to exchange 1 from the hundreds and move it to the tens. It still doesn't help me now to do this one. So already I've finished doing that. I'm on to the next question. So hopefully you can see that this one, because of those numbers, is a much more efficient way of doing it. Okay, 10 subtract 5 is 5. 9 subtract 9 is 0. 9 subtract 8 is 1. And then we've got nothing there. Okay, so we do get the same answer, but it took probably about 5 times as long. And what I would say is that lots of you would have made mistakes by exchanging from this column and then take it straight to this column. So this is much more likely to get you the right answer, and it should save you time. Okay, right, 0.9 multiplied by 4. Now, hopefully you looked at this and didn't panic, because actually what you should have been thinking about is, what fact do I know that's linked to this that I can then manipulate, I can change slightly to help me answer this question. And hopefully you thought, hang on a minute, I know 9 multiplied by 4. I apologise for this writing. 9 multiplied by 4. Now, 9 multiplied by 4, if you don't know your times tables, this could be a bit tricky. However, think about one that is really close to it that could help you. So what's 10 multiplied by 4? Yep, that's 40. So if I've got 10 lots of 4 and I only want 9 lots of 4, then that makes sense. I've got to just take 4 away, subtract 4 from 40, which is 36. Okay, so if my question was 9 multiplied by 4, the answer would be 36. However, I've just got to think, what did I do, okay, to get from 0.9 to 9? Now, I multiplied this by 10, okay, because if I times by 10, I'm moving everything up one column. So my 9, instead of being worth 9/10, is worth 9. So in order for me to get back to do 0.9 multiplied by 4, I just need to divide this number by 10. Okay, so I'm going to move everything down one column, and I get the answer 3.6. Okay, so there we go. So the number that I times, so I've got, instead of 0.9, I've times it by 9. I had to make that number 10 times bigger. So if I want to go back, I need to make my answer 10 times smaller. So that's why you get the answer 3.6. Okay, the number today, or not the number, I apologise. Actually, yeah, let's make it a number. Okay, so the key word today to get you 10 dojo points to prove that you've watched this is million. Okay, so you can either write it in digits or you can write it as a word, so million. Right, this is a question that is very closely linked to the short fraction video you should have watched before. So we're trying to find a fifth of 35. So instead of breaking up like a pizza or a cake or a shape into equal parts, we're now going to look at finding fractions, okay, of whole numbers. Now, when you're finding a fraction, remember you're splitting it up into equal parts. Now, we're going to split this up into 5 equal parts. So what we need to do is to divide, very simply, 35 by 5. Okay, so you're thinking about the actual maths you're doing is 35 divided by 5. And I really apologise for the writing. Okay, so then this becomes a simple times table question because there are 7 lots of 5 and 35. So 1/5 of 35 equals 7. Okay, that is the answer you're looking for. Right, now we've got over to the other side of the board. Now these two fractions, you know by looking at them, because of the denominator, the bottom number, you know that you need 5 equal parts for both of them to make a whole. So our denominator stays as 5. And then all we have to do is to add the numerators, add the top numbers together. So 3 add 4 equals 7. Now, if you are happy to leave that as your answer, that is brilliant, but that is an improper fraction. So that's where the top number, the numerator, is bigger than the bottom number, the denominator. And that would be a big tick. Yes, that's correct. However, you could show a little bit more of an understanding of fractions by changing it to a mixed number. And a mixed number shows how many wholes and how many part wholes you've got. So for this fraction, we need 5 out of 5 to have one whole. So I'm thinking, how many lots of 5 can I get out of 7? 1. Okay, so that 1 is my 5 over 5. Okay, and then I'm thinking here, I still need 5 parts, 5 equal parts to have my whole. So I've got my 5 out of 5, so I've taken 5 away from that 7, and I've got 2 left. So either of those answers would be correct. Okay, right, the next one. Again, thinking about doing this in your head, because if you did this as a sum, it would take you quite a long time, and you could be making some mistakes with exchanging. So we're thinking about, we've got 7 subtract 0.89. We know our answer must begin with 6 and then a decimal, okay? We know that because we're taking away less than 1. If we had 7 take away 1, it would be 6. Okay, anything more than 1, it would be something else. But because we're taking away less than 1, we know our answer is definitely 6 point something. Now we're looking at this here. We've got 89 hundredths. Okay, so 8 tenths and 9 hundredths. Together they make 89 hundredths. Now you've just got to think, I need 100 hundredths to have a whole number. Okay, so we have to think, what do we add to 89 to make 100? So add 1 to it makes 90, then add 10. So the answer is 6.11. Now, if you did a sum, like column subtraction, you may have got it right. But again, it would have taken you much longer. There is much more of a chance of getting it wrong because of the exchanging. So hopefully you can do this mentally. And as I said, count up, but use that knowledge of you need 100 hundredths. Okay, right, 7 multiplied by 20. So again, use something that you know really clearly and then manipulate it. Okay, so change it slightly for the sum that you actually want to do. So the knowledge we're going to use is 7 times 2. 7 multiplied by 2 is 14. Now, the number we're timesing by 7 is actually needing to be 10 times bigger. So all we've got to do is to make our answer 10 times bigger. So 140 is our answer because 14 times 10, okay, is 140. But we can prove it by moving each digit up 1 column and then filling our gap with a placeholder of 0. Okay, so the answer is 140. Now, this is our word problem for today to do with measurements, all right? I have a 2 metre piece of material and cut it into 2 pieces. So I'm going to underline, I'm going to use our favourite 3 letters, and today I think we're going to need to do all 3 of them. So I've got 2 metre, it doesn't matter that it's a material, okay, and I cut it into 2 pieces. So that 1 piece becomes 2 pieces. Now it says 1 piece measures, so 1 piece measures 70 centimetres. And the question we're trying to answer is how long is the other piece in centimetres? So what I'm going to do here is show you what I've done. So I have drawn something that represents, it's a rectangle that represents my piece of material. I know from here to here it's 2 metres, but I've cut it. So what I'm going to do is I'm going to say, hang on, I've cut it and one side measures 70 centimetres. Now if I cut it exactly in half, say roughly here, there would be 100 centimetres on either side because it's 2 metres long and half of 2 metres is 1 metre, all right? And I know 1 metre is the same as 100 centimetres. Now I've cut it so that one piece is 70 centimetres, so I'm going to do that there. And I'm just going to write down here for myself that this is 70 centimetres. Now that is really badly written. Okay, now I'm thinking, hang on a minute, I've got this in centimetres, I've got this in metres. I'm going to, underneath this, write that I know 2 metres is the same as 200 centimetres. Because for every metre I've got, it's 100 centimetres. So I've got to think, okay, from here to here is 200 centimetres. I know up to here is 70 centimetres. So all I've got to think about is what do I add to 70 to make 200? So again, I'm using that number line in my head and I'm going to start at 70, okay, and I'm going to add 30 to it to make 100 centimetres. And then from 100 to 200 centimetres is another 100. So the answer I'm looking for is 130 centimetres. Now I can check that I'm right by adding these 2 numbers together and making sure that they equal 200, which they do, because 30 adds 70 is 100 and then the other 100. Okay, so the answer you're looking for the first part is 130 centimetres. The challenge, it says how long is the second piece of material in metres? So you need to show 130 centimetres as metres. They're the same length, but we're expressing it, we're showing it in different measurements. So I know that there are 100 centimetres, okay, in a metre. So I know that 100 centimetres in 1 metre means that I have to divide my answer by 100 because I've got to have 100 centimetres to have that metre. So it's 100 times smaller my number's going to be. Okay, so I'm going to divide this by 100. So I'm going to move it down 2 columns. So 1 column, 2 columns. I'm going to put my decimal point in and then I've got my, there we go. So I've kept everything in the same order and I've just moved each digit down 2 columns because remember in 100, if we're dividing by 100, the little clue there is that we've got to move it down 2 columns. So that is our answer. Okay, 1.30 metres. Now, lots of you will have said, I would have thought, would have said that you wouldn't put that one in. So 1.3 metres is the right answer as well. But if you had 1.30, that's fine. Okay, let me know how you've got on. Make sure you mark it carefully, and I'll see you soon.